Hello everyone, and welcome to my SP2 channel. This video is all about the ionic compounds. We're going to be looking at cations and anions, a little bit on the polyatomic ions, and kind of formation of the ionic compounds. And then at the end, we're going to do a practice together. Okay, so starting by introduction to ions. So ions are atoms or molecules that they carry an electric charge, and that is because either they lost or they gain electrons. And they are generally classified as two main types. We have either cations or anions. Okay, so starting by cations, by definition, they are positively charged ions. And if you think about how they form, right, like formation of your cation, that is because the atom lost electrons. Could be one electron, could be more than one. And here are a couple of examples for you. We have sodium ion, which is Na plus, and this plus or the positive charge is going to be presented on the, top right corner in a form of, superscript, right? So you can say sodium ion, and it's being formed because sodium atom lost an electron, right? Another example is like calcium ion, where we have Ca, calcium, and then we have 2 plus, which is presenting the charge, meaning that the sodium atom here lost 2 electrons, right? Now, for the anions, they are by definition the negatively charged species, right? And if you think about how they form, they must gain electrons. And here are examples. We have chloride ion, right? Cl with a negative charge. And that is because chlorine gain an electron. Or you can say oxide, that's another example, oxide ion, where we have oxygen with 2 negative charge because the oxygen here gains 2 electrons. Okay, now sometimes we have more than one atom, right? So we call them polyatomic ions. So these are the ones that are ions consist of 2 or more atoms bonded together, and they must have a net charge, right? And again, they could be either positively charged, which is cations, or they could be negatively charged, which is our anions. Now, if you think about why they have these charges, right, you can think about the total number of electrons is not equal to the total number of protons in the molecules, right, or even in a group of atoms. And I have a couple of common examples for you. The first one is ammonium, right? Ammonium, that's NH4, and you've got positive charge, so that's a cation. We have hydroxide, which is OH with a negative charge. That's an anion. We have nitrate, NO3 with a negative charge. That's another, anionic polyatomic ion. And the last one is carbonate, CO3, and we also have 2 negative charge here. Okay, now in terms of the ionic compounds, kind of formation of these, right? You can think about the chemical compounds that are formed by the electrostatic attractions that we always have between the opposite charges, right? Which is your cations and anions. They are typically formed between a metal and a non-metal, right? So what happened here is for your ionic compounds to form, we need to have electron transfer. And typically the metal is the one that is losing electron to form cation, and the non-metal is the one that is gaining the electron to form the anion. So that means the electrons are going to be transferred from the metal to the non-metal, right? That's how we can gain these kind of opposite charges. And here are a couple of examples for you where we have sodium chloride, right? That is table salt, right? So you can think about sodium, which is our metal, right? Lost an electron to form Na plus, and then chlorine, which is a non-metal, is the one that is gaining that electron from sodium, right? So the interaction that I have between sodium plus and chloride with a negative charge is known as your electrostatic attraction, right? And together they're going to give us an ionic compound. So as you can see, the charge must be always balanced, right? We always need to have equal positive and negative charges in order to balance out our overall charge for any given ionic compound. There's another example, which is magnesium oxide, right? Where we have Mg, that's our magnesium, lost 2 electrons to form Mg2 plus, right? And then I have oxygen gaining 2 electrons to form oxide. So together I have magnesium oxide. Okay, so there we are. Here is our practice. It says write the chemical formula for the compound formed by the first one is aluminum 3, and then you have your chloride, right? So the cation is aluminum and the anion is our chloride. Because I have 3 positive charge, I need to have 3 negative charge. So I need to write it as Al aluminum and then Cl3 to balance out the charge, right? The other one is with aluminum 3, and now we have oxide. So the oxide by itself has 2 negative charge, right? So I need to have 2 of the aluminum and 3 of the oxide to balance out my charge, right? So keep that in mind. For all of these ionic compounds, your charge must be balanced. Okay, thank you so much for watching again, right? So if you found this video helpful, again, don't forget to give it a thumbs up, share it with someone who might find it useful. If you really like and you're enjoying the content and you want to keep learning with me, you can hit that subscribe button, right? You can turn on your notification bell so you're not going to miss out any of our future videos. As I told you before, I'd love to hear from you guys, right? So if you have any questions or you have any specific topics that you would like me to cover that for you in our next videos, just let me know, right? You can drop a comment below. And don't forget that your support means the whole world to me and is super helpful for growing my channel. Thank you again, and I'll see you on the next one. Bye-bye for now.